So this collaboration known as the Event Horizon Telescope took the first ever picture of the black hole at the center of our galaxy, the Milky Way. So this is a black hole that's 4 million times the mass of our sun. And we've known that it's there for probably at least 20 years, if not more. And the way we've known it's there is through the motions of stars near the center of our galaxy. We see these stars sort of whipping around, and their orbits tell us that there has to be some very massive compact object right at the center of our galaxy. Something that's 4 million times the mass of our sun, but in a region that's less than a tenth of the distance between the Earth and the sun. So just a very compact object. But those observations are kind of indirect. We sort of indirectly know that there's a black hole there. What's amazing about this picture that the Event Horizon Telescope took is that it's the first direct proof that our galaxy contains this black hole, this supermassive black hole. If you look at the image, you're seeing, the glowing part of the image is the hot gas that's accreting onto the black hole, basically swirling around the black hole and falling into it. And as it falls into it, it gets heated up, and you're seeing the emission from that hot gas. But then at the center of that image, you see this black region, and that black region is, of course, the black hole. What a black hole essentially is an object that's so compact, has so much mass and such a small volume that the escape velocity is greater than the velocity of light. So the escape velocity from Earth is, I don't know exactly, but a few kilometers per second. The escape velocity, the light travels at 300,000 kilometers per second. So from a black hole, the escape velocity is even larger than that. So not even light can escape. So nothing can escape. It's basically a point of no return. And so that black region is black because no light can escape. And so we're essentially seeing the black hole from the lack of light coming from that region. It's extremely groundbreaking, and I should say I'm not a member of this collaboration. I'm just a keen outsider that's very excited about these results. But they're going to be able to, and already are able to, test our understanding of gravity and our best theory of gravity, general relativity, in unprecedented ways, in a regime that hasn't been tested before, in what's called the strong gravity regime, where the gravity is very strong. We've done tests in other environments, like in the solar system, where gravity is relatively weak, but this is really one of the few places where we've been able to test it in this strong gravity regime. The prospects are also really exciting. As this telescope improves its capabilities, we're going to be able to make stronger and stronger tests of general relativity and see if it's really the right theory of gravity. Ultimately, we know it's probably that there is a deeper theory of gravity that connects general relativity with quantum mechanics. So one of the questions is, will that be noticeable in these future observations? The other thing that's amazing about this observation is the collaboration itself. So it's called the Event Horizon Telescope. But it's not really just a single telescope. It's in fact a global network of telescopes. Institutions, dozens of institutions around the globe, with hundreds of collaborators. And the way it works is they all agree to point their radio dishes, the radio telescopes, at the center of our galaxy in the constellation Sagittarius at the same time. The reason you need to do that in order to make this kind of observation is you need these telescopes that are separated on the scale of the size of the Earth, and that allows you to take a really high resolution image. So to give you a sense of how high resolution it is, they're basically resolving something the size of a baseball at the distance of the moon, right? That's how small that black hole is, given that it's 26,000 light years away. And so the only way they can do that is by having this global network of telescopes spread across the Earth, and using a technique known as interferometry. So it's obviously both an amazing scientific accomplishment, but also an amazing collaborative accomplishment across many institutions and an international effort.